Okay, today we're going to talk more about slope. We're going to learn how to find slope when it's not on a graph, and instead when they give us the information in a table. Okay, now this is there's a lot more like adding and subtracting involved with this, and not so much just like counting. Okay, we're not just going to be counting the vertical change and the horizontal change and making our fraction that way. Instead, we'll be doing some subtraction or some mental math most of the time to figure out our change in x and our change in y. You'll remember yesterday we talked about finding slope on a graph where they gave us 2 points along a line, and they asked us to figure out the slope, figure out the vertical change over the horizontal change. Okay, now they wrote it again for us right here. Okay, they wrote it again for us right here. They have slope is the change in y over the change in x. Now, here in this little sentence at the very top of this page, they say that the Greek letter delta, okay, which is this little triangle right there, that is the Greek letter delta. The Greeks used symbols. We have our symbols for our letters A, B, C, D, E, F, G, so things like that. The Greeks had theirs as well. They had alpha, beta, gamma, and so forth. And this is the Greek letter delta, okay? And it's used to represent the words change in. So I've told you before how mathematicians were looking for the easiest way to write something down. We don't like writing a bunch of words. We don't like writing sentences. We use symbols as much as possible. And so someone way back when, sounds like back in the Greek times, they decided that instead of writing out the change in y, they were just going to use the delta, the Greek letter delta y, to show the change in y. This means the same thing. Delta y means change in y, the vertical change. And delta x means change in x, okay, the horizontal change. So we're not doing anything different today. We're doing exactly the same thing we did yesterday, except instead of it being on a graph, it's going to be on a table. So let's kind of look through example 4 here and see how this is done. Okay? All right, so I'm going to use my little pointer here to point out what I'm talking about. Here we have a situation. Apparently they are comparing distance to the number of hours. Okay, probably number of hours traveled or something like that. Okay, so we have our x values over here, 1, 2, 4, 6, and 10. We have our y values right here, 4, 8, 16, 24, and 40. Now, they want us to figure out the slope. Well, we're going to follow this whole change in y over change in x, delta y over delta x. Okay, and we're going to use this table to show some of our work along the way. Now, I'm going to zoom in just a little bit so it's a little easier for me to write. Okay, now, you'll see that right here, in order to figure out the change in x, okay, right here, they took this x value and they subtracted the x value from right before it. Okay, so that was 2 minus 1. So our change in x was just a positive 1 here. Okay, for the change in y, they did the same thing. They took this y value and subtracted the y value from right before it. Okay, what I mean by right before is if you're reading this table, you read from top to bottom, don't you? So if I choose 8, then the number before the 8 is the 4. Okay, so they did that. They did 8 minus 4 here. So their vertical change, or their change in y, came out to a positive 4. So we have a vertical change of 4, a horizontal change of 1, or a change in y of 4, and a change in x of 1. So 4 over 1 simplifies to 4. Now, if this truly is a linear function, then our change in y over change in x, our slope should stay the same no matter which set of data we choose. Okay, kind of like on the graph. It didn't matter which points you chose on the graph. We were able to find the exact same slope no matter what. Okay, so if we do this on the next level, give me just a second. Okay, if we do this on the next level, our change in x, okay, so here on this level, okay, on this row right here, we're going to start with our x value. We're going to start with 4. Okay, so start with our 4 right here, and we're going to subtract the x value that's right above it. We're going to subtract the 2. Okay, so we're going to subtract the 2. So 4 minus 2 gives us 2. So that's our change in x. So if I go over here to the last little cell here, I'm going to put my 2 on the bottom here because the change in x goes on bottom. So there's my 2 right there. Now we go and we fill in our change in y box. Okay, so we're using the y value from this row, this guy right here, and we're going to subtract the y that was right above it. Okay, so we're going to do our 16 minus 8, and that gives us, what is 16 minus 8? 8. So our vertical change here is 8. So we have a slope of 8 over 2. Well, 8 over 2 can simplify, can't it? 8 over 2, 8 divided by 2 gives us 4, which is a good thing because our slope, if this is a linear function, our slope needs to match. Okay? It has to match all the way through the table. Okay, our slope has to match all the way through the table. So if our slope is 4 here, it should be 4 here, and it should be 4 here, and hopefully it's going to be 4 here also. Well, let's do the work to double check. Okay, let's do the change in x. So we choose this row's x, that's 10, and we're going to subtract the x right above it, which is that 6. So 10 minus 6 is 4. Okay, so our horizontal change, our change in x here is a 4. All right, then I go and I do my y values. Okay, we start with this row's y, which is a 40. Okay, and we're going to subtract the y value from right above it. Okay, which is 24. 40 minus 24 gives us 16. So we fill that in on our slope, our vertical change, or our change in y. Okay? And what is, if we simplify, what is 16 divided by 4? Well, our final here is 4. So that's a good thing. It's a good thing that we got the same slope no matter what row of the table we were looking at. Okay, we got the same slope no matter what. All right, let me zoom out a little bit. So, in conclusion, for example 4, what can we say our slope is? Well, if you look in this column right here, the slope column, we have all of our rows say that our slope is 4. So I'm pretty sure that our slope is going to be 4, since all our rows say that, right? It just kind of makes sense. So if our slope is 4, that means that when x increases by 1, when my denominator, when my x change is a positive 1, my y was a positive 4. Okay, so that means when x increases by 1, y increases by 4. Okay, that's what the slope tells us. Okay, the bottom number tells us how much our x is moving. The top number tells us how much our y is moving. And so when x goes up by a certain amount, y has to go up by a certain amount. And that's what a ratio tells us, what this fraction of slope, what it actually tells us. Okay, now let's look at this next example. Okay, let's look at this next example. You'll see that they filled in some parts of the graph, but not all of them. So we get to kind of fill in what they're missing. Okay, so let's just repeat this process. You'll notice that in this first cell right here, this first block, we're doing our change in x. So they took the 5 from this row and they subtracted the negative 2 from the row above it. Okay, we're doing the x values. So 5 minus a negative 2. Now, when we subtract a negative, what does that mean? Well, if we're subtracting a negative, that means we're actually adding, right? 2 negatives make a positive, 2 minuses make a plus. Okay, so 5 plus 2 makes 7 right here. So our change in x value is going to be a 7 in our fraction, our ratio over there. So let's do our y now. Well, our y says 13 minus the y above it, which is 27. Okay, 13 minus 27. Okay, I have more bad guys. So they're going to fight each other. One's good guys, one's bad guys. They're going to fight each other. They're going to duke it out. And the bad guys are going to win. So I'm going to have negative, and what's the difference here? Well, negative 14. So that's my change in y. That's what I put on the top of my fraction here, negative 14. Well, when I go to simplify this fraction, negative 14 divided by 7, okay, negative divided by positive is a negative, and 14 divided by 7 is 2. So this is a negative 14 over 7 equals negative 2. This is a negative 2 slope. Now, if this is a linear function, which we hope it is, because that's what we're talking about, what we're learning about, okay, if this is a negative function, then all the rest of these slope boxes, all the rest of the answers in this box should equal negative 2. Well, we can't take that for granted. We've got to figure that out. We've got to make sure that that is true. So let's go through our data. Okay, in this row, this next row here, we have 6 minus 5. We're doing our change in x, so we took our 6 from right here, and we subtracted the one above it, right? Okay, so we subtract the one above it. 6 minus 5 gives us 1. Okay, so that's the bottom part of my, that is the bottom part of my slope, okay, because the x always goes on bottom. So this is a 1 right here. They already worked out our y for us, okay. They did 11 minus 13, and they got negative 2. There are more bad guys than there are good guys, so we ended up with a negative, and the difference between 11 and 13 is 2. So we have a negative 2 here. So if we simplify our slope here, we have negative 2 over 1. Negative 2 divided by positive 1 leaves us with negative 2. So far we're doing good. Our slopes match up in this column. We're doing pretty good. Let's continue our work. Okay, change in x. We're going to take our 8 and subtract the 6 from above it. So 8 minus 6 is 2. Okay, so that means the bottom number of our slope here is a 2. Then we move on and do our change in y. Our change in y here, okay, our change in y is 7 minus the 11. Okay, 7 minus 11. We've got good guys and bad guys. Okay, so we're going to have more bad guys than good guys, so it's a negative, and the difference between 11 and 7 is 4. So my top number of my slope is negative 4. Well, negative 4 divided by 2, if we simplify, makes a slope of negative 2. We're on the right track. All our slopes are matching. That's good. Let's do it one more time with this last bit of data. Okay, we have 13 in this row for our x, and we subtract the 8 from the row above it. 13 minus 8 gives us 5. So the bottom number of our slope is 5. Then we move on to our y's. They already set it up for us. They had this negative 3, and we're going to subtract that 7 right there. Okay, so negative 3 minus 7. Negatives and minuses, they're bad guys, right? So we have 3 bad guys, and we're subtracting 7. We're going to bring 7 more bad guys in. Okay, so they're not going to fight each other. They're like, you're a good bad guy, I'm a bad guy, let's be friends, right? So 3 bad guys and 7 bad guys makes a total of, sorry, my pen stopped. Oh, hello, stop this. Stop this nonsense. Why is it doing this? There we go. Sorry about that. Negative 3 minus 7. Okay, so 3 bad guys and 7 bad guys makes a total of 10 bad guys. Okay, so I'm going to fill that in over here. And finally, to simplify our slope, negative 10 over positive 5 gives us a negative 2. So the awesome thing is all our slopes match. That's good. Okay. So what does this mean? Well, what does it mean to have a slope of negative 2? Our slope equals negative 2. What does that mean? Well, if you look at this ratio that we came up with, okay, where we had negative 2 over 1, this means that when x is a positive 1, when x increases by 1, my y is a negative 2. So my y is decreasing, or decreases. My y decreases by 2. So when x increases by 1, when I go to the right 1 space, I should go down 2 spaces because we have a y change of negative 2. Okay? It decreases by 2. That's what negative 2 means. Okay? So when we're looking at tables, we're still looking for the change in y and the change in x, just like we did on a graph. Okay? On a graph, okay, let's go to this graph here, and let's say we have an example of, let's just pick 2 random points. Let's say this point right here, and we'll do, I don't know, this point right here. Okay, now, 2 random points. All right, what is the ordered pair for the top left point? Well, this top left point here would be, let's see, 1, 2, 3, 4, 5. So negative 5. And its y value would be 1, 2, 3, 4, 5, 6, positive 6, okay? And this guy over here would be a positive 1, negative 3, okay? So we have these 2 random points on the graph, okay? Now, we have practiced, you practiced yesterday, and we did a little bit on Friday and things like that. We could just count the vertical and horizontal change, couldn't we? We could do our vertical change. I'd been doing that in blue on the other page, so let's do it in blue here. Vertical change, okay? I could count how far I have to go to get even to the next point, okay? This would be 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be a negative 9, okay, because we went down. Okay, so it could be a negative 9 change for our vertical change. And then when we do our horizontal change, we would go across like this to get even to that point, right? So that would be a horizontal change of 1, 2, 3, 4, 5, 6. Okay, so 6 right there. Now, that's a positive 6, right? Because we're moving from the left to the right. Okay, so that's a positive 6 change. Okay, so this is a positive 6 change. So our slope here, we would write it as negative 9 over positive 6, which would simplify, if you think about it, they can both be divided by 3. This would simplify to negative 3 over 2. Okay, you divide both those numbers by 3, and you get negative 3 over 2. Now, we did that on the graph all sorts of times. We did it on the computers on Friday. We did it as practice yesterday, okay? But this was on a graph. What if we set up a table instead? What if we took this information and we set up a table on the side here? Okay, if we set up a table on the side, we create our nice pretty little table. I'm going to try to create a nice pretty little table, okay? Remember that our x's go on the left and our y's go on the right. So let's write in these 2 ordered pairs real quick. We have negative 5, 6, and 1, negative 3. Okay, so we have these 2 pairs. If we were to do what we just did on the previous page, now I know this isn't in your notes, okay, so maybe you're writing this down on a separate sheet of paper or in some blank space, okay? Let's do our vertical change, our change in y. How do I get from a from a positive 6 to a negative 3? Well, if we do this mentally, if we just think logically about this, to get from a positive to a negative, we have to go down. So that's going to be a negative number. And to get from 6 to 0 is 6 spaces. From 0 to negative 3 is 3 more spaces. So that's a total of 6 and 3 makes 9. So we have a vertical change, a change in y of a negative 9. Okay? I'm trying to write that nicer each time, and it seems like it's getting worse. Let's undo this. Let's try this again. Okay? A negative 9. Ah, that's better. Okay? Then we look at our change in x from a negative 5 to a positive 1. Well, logically, that says we've got to move in a positive direction, right? From a negative 5 to a positive 1 is a positive change. And we'd have to go how many spaces? Well, 6. Okay, so now, just from this table, we have a vertical change, or change in y, and we have a horizontal change, or what we call change in x. Okay, so we have this. We write it down just like we always do, change in y over change in x, which happens to match what we did on the left side of the graph there. When we simplify this, divide everything by 3, we get negative 3 over 2. This slope matches that slope. Do you see that? This slope that we got when we did it on the graph and this slope we got when we did it on the table. They match exactly, negative 3 over 2. So it's just another way of finding slope. It's another way of finding the slope between 2 points. Now, tomorrow you're going to practice finding slope from a table. Okay? Well, I'm going to give you several different tables of data. You're going to find out the change in y versus the change in x, and you're going to just practice it over and over and over again. Okay? There will be a couple special cases, okay, and I want you to try them. I probably won't grade them on this particular homework as part of the homework, but there will be a couple special cases, and I want you to try them. We're going to cover special cases a little bit more on Thursday, and you'll get a chance to practice those on Thursday. Okay? So you've got these notes. I want you to spend the rest of this class just kind of reading over these notes, maybe having a short, quiet discussion with your neighbor or a small group about these notes, ask each other questions, things like that. But this is how we find slope based on information in a table as opposed to information on a graph. Okay? So tomorrow you'll practice finding slope on a graph. That's what your assignment will be during class. And as always, if you don't finish, it becomes homework. And if you do finish, use your time wisely afterwards. On Thursday, we'll get into our special cases and how to find slope if you're just given 2 points. Now, I sort of touched on that here in this last slide, but we're going to look at it a little more in depth and talk about what's called the slope formula on Thursday. Okay? All right, so spend the rest of this class time, if there's much class time left, spend it either finishing yesterday's homework if you didn't finish it like you were supposed to, or work on any work you have for other classes or missing or late work for me. All right.